what I want you to do is just up top here, if you just drew a graph, like I don't, it doesn't have to be fancy, just go like this. Okay? Okay, just something like that. Now, if I asked you on that graph, what are the factors? X-intercepts, aka roots, okay? So, that's the same thing when the remainder equals 0. Okay? So, this is when your remainder equals 0. It means it's a factor. It goes in really nice. There's no remainder. 8. The factors are 1, 2, 4, and 8. Why are they the factors? Why doesn't 3 get to be a factor? Because if you put in 3, it doesn't divide nice. There's a remainder. Okay? But does that mean it's not even on the graph? No, it doesn't mean that. It is a point on the graph. So if I, who knows? Let's just say this is 2. Okay? 2 is a factor. Now, if I put 1 in, so let's say I put in 1, I'm going to get like -2 as my answer. Okay? See, 1 is not a factor, but it still gives me a point on that graph. So this is the remainder when x equals 1. So that would be point 1, -2. See, the y is always the y on the graph. If I plug in an x and I get out a y, that's my xy. That's the point on the graph. So everything that comes out when I put a point in, and we've done this before. We've done it. You've done it in grade 10. Put in the x values, get out the y's, draw a bunch, points, and then draw a line. Okay? That's exactly what we're doing here. So when I use synthetic division, I put 1 in, and I get 32. 1, 32 is a point on the graph. The thing that we're always really looking for is what makes the thing equal 0? Because if it equals 0, that's a factor. Okay? That's the remainder. So when we see these two theorems here, the remainder theorem and the factor theorem, they are the same theorem. The remainder equals a number, okay? That is not 0. That is a remainder. A factor theorem is when, so I should say the remainder, the number is not 0. This is the remainder is 0. I know it seems kind of funny, like, what? That's not a theorem, that's what we already did already. We did that last class, yes we did. So today is going to be 100% review of that one question we did last class. But it's like, okay, you know how it works, right? How are they going to twist this information? So I have to know so many other things to actually pull this one off. Okay, that's what the diploma is all about. They don't just say, hey, what is the factor theorem? And you got like 4 definitions to pick from. It'd be nice if it was that easy, but it isn't. Okay, so let's actually go down to here and talk about the remainder theorem. Now the remainder theorem, it's when a polynomial is divided by a binomial and the remainder obtained is equal to the polynomial when x equals a. So when you put in an x and you get out a y, that's x comma y on your graph, okay? Now x comma 0, 5, 0. Hey, that's on the x-axis. That's actually the solution, or it's a factor, okay? So let's just start doing some questions, right? You got to, like, what kind of questions could they ask? Okay. Now, use the remainder theorem to find the remainder when p of x equals 6x mouse. Now, this is the easiest question in the world if you know the one little thing. What number am I putting into that? -1. Okay? So we are going to put -1 in. So 6 times -1 cubed minus 4 times -1 squared plus 8x, or 8 times -1, sorry, plus 6. Okay? Now just be careful, right? This one here, man, this catches a lot of you. Some of you guys go 4 times -1, and you square the 1, right? You can't do that. It's -1 squared times -4. So you will get a negative answer over there. So anyway, this one, let's do this in order, I guess. Where am I? This is -6 minus 4 minus 8 plus 6. This equals -12. So when I get a remainder, I got to go, hey, that's actually a point. -1, -12. So I did. I came up with, if you got a remainder, things were bad. Okay? It's not a nice number. That's all I kind of got from that. But it's actually just a point on the graph of that equation. Okay? So even when you were doing little, 8 divided by 3, and you weren't getting the nice little number, you're getting a remainder. Okay? That is just like your point on the graph. What would I put in? We don't have to do it, but let's do 2. What number would I put in? 1/2. Okay? So you put in 1/2. Remember, what you want to do, so I'll just -1. You want to do, what would make this equal 0? Okay? What would make this equal 0? That's what I'm doing to find the number that I'm going to sub in. That's a point that people get confused a lot. Okay? Less of you will be confused on the unit exam because I'm going to drill it into your heads as much as possible. But what's going to happen in 3 months? Like, have you really highlighted that? Right? So that sticks out. That's probably the first thing you see when you read your study sheet. Yes? Yeah. So hold on. Okay, what is the 0 there? What makes it equal 0? Yeah, that's why. If you make this equal 0, do that equation. Both work. Yeah. Yeah, if both didn't work, then one of them is wrong. We've done something wrong. We just did one like this on the exam. So let's go to example 3. Okay? Example 3 is an absolute nightmare if you do not know the remainder theorem. Like, this is a good numerical response question that I would see on, it asks you, find the coefficients of C and D. But they always say this, find the coefficients of C and D. What would be their sum? Put this in the box below. Okay? And it's not a tough question, but man, you got to know lots of math for this one. Okay? Now the first thing is, okay, they tell me that when I divide this by x plus 3, I get a remainder -41. They also told me I get a remainder of 74 if I divide by x minus 2. Now, why do they have to give me 2? Because I have 2 variables. Because I have 2 variables, I need 2 equations. Okay? There's 3 variables. I need 3 equations. So all you have to do is you've got to plug in, well, first of all, what should I plug in to get the negative 41? Negative 3. So I'm just going to go 2 times negative 3 to the 4 plus d times negative 3 to the 3 minus c times negative 3 squared plus 5 times negative 3 minus 8 equals negative 41. This is not a nice question. Okay, so if you add this entire side up, okay, this is 162 minus 27d minus 9c minus 15 minus 8 equals negative 41. Now, do you see that these can be put together? Okay, and what do we get? No, negative, because of the negative 3. What, 139, is that right? Negative 139? No, positive 139. So we get negative 27d minus 9c plus 139 equals negative 41, right? If you bring that to the other side, you're going to minus 139 to both sides. You will get negative 27d minus 9c equals negative 180. Now, this is a step that if you didn't do it, you would still get it right. But do you see, if everybody, not just most of them, if everybody can be divided by a number, you can do it. What number could we divide by? 9. Or, better yet, I'm going to go with negative 9. So I'm going to divide by negative 9. So that'll give me 3d plus c equals 20. Now, when you're going on a test, sometimes those things don't pop out. Okay? And that's okay. You're just going to have a bit bigger numbers at the end. This course, if you can always keep things simple, it is faster to do. Right? And that's why when you practice these enough, you learn how to be able to make them simple as well. Now, the next one, we're going to plug in what to get 74. So 2 times 2 to the 4 plus d times 2 cubed minus c times 2 squared plus 5 times 2 minus 8 equals 74. That's 32 plus 8d minus 4c plus 10 minus 8 equals 74. Okay, if you get all that together, 34 minus 12. No, sorry. 32 plus 10 is 42. Minus 8 is 36, right? So if I got 36, I'll write that down. 8d minus 4c plus 36. 34 equals 74. Okay, minus 34 to each side, and I will get 8d minus 4c equals 40. Again, you may not see this step, but it's not going to kill you if you forgot it. I can divide everybody by -4. Or divide by 4, I'll do. So that is 2d minus c equals 10. Two equations, two unknowns. You can subtract the two, you can add the two. In this case, so I got 3d plus c equals 20. And 2d minus c equals 10. Okay. Now, again, add them. Why? It gets rid of a variable for me. I will get 5d equals 30 divided by 5 divided by 5. d equals 6. Okay, if I got d equals 6, I can plug it into any equation, doesn't matter. Since I did the first one last class, I'm going to mix it up a bit. I'm going to put in the second one. So 2 times 6 minus c equals 10. I got 12 minus c equals 10. Okay, if I subtract 12 to both sides, I'll get negative c equals negative 2 divided by negative 1. C equals 2. Okay. Now, the factor theorem is the remainder theorem, but the factor theorem is when r equals 0. Okay, so this one, we've already done a review in that one, but here's, if p of 3 equals 0, what's the binomial that I would write for it? X minus 3. How about b? What would be the binomial I would write for it? 3x plus 2. Okay, how about this one? This is like, again, one of those questions like, huh? What do you mean? Okay, if p of 5 equals p of negative 2 equals 0, what is the binomial? What's the second degree, which is called the quadratic? What would be the quadratic fraction then? This is a really easy question, but if you kind of don't understand the language, it's like you'd never get it. This is one of those 20-second questions if you know what it's asking. If p of 5 equals 0 and p of negative 2 equals 0, what's a different way to write p of 5? That's x minus 5, right? What about p of negative 2? X plus 2. Now I just FOIL it. X squared minus 5x plus 2x is minus 3x minus 10. Quick question. That's it. There it is. That is the equation that has, and if I put in 5 in there, I'll get the answer 0. If I put negative 2 in there, I get 0. They're roots. That must be the solutions. Okay? So I'm trying to kind of tie in the graphing with this because that's what I need you to have by the time you walk out of here. That's why I'm saying you use your calculator so often, because except for the perms and coms unit, everything else can be part of the graph. Okay? So how do you know if x plus 2 is a factor? Yes, you can do long division or synthetic division, but if you just put in negative 2, you will know as well. Now that's going to come in handy because you are not going to have time to do synthetic division 10 times before you get it, okay? Now, you don't know this now, but you will. This is the things I test, all the stuff that go into 4. Okay, so 1, 2, or 1, negative 1, 2, negative 2, and 4, negative 4. Those are things I will test. It's easy to put those in quick if I just use the factor theorem. But if you put in 2, so if you get 4 times negative 2 squared minus 16 times negative 2 squared cubed, squared minus negative 2 plus 4. If you do all this, you get the answer negative 90. It is not a factor, because it would equal 0 if it was. Okay, you'll get a question like, number 1, for sure on the quiz, maybe even the diploma. Okay, this one's a little too easy for the diploma because the way, if I really wanted to find the roots, I would graph it and find the x-intercepts. Okay, now if you have no idea that roots are the same thing as x-intercepts, you wouldn't go down that road, right? I guess the hope is that you've written out a few times somewhere that you know roots equals x-intercepts equals zeros and factors, right? Okay, now this one says find the other roots. Now this is a good algebraic question. Show that 1 is a root. Well, they actually give us one of them, one of the factors. So if I put 1 in there, I will get, well, let's do synthetic division. Now, they say show that 1 is, so I would just do, I'd put it in. It does equal 0. The unfortunate thing about the factor theorem, it only tells you if it's a factor. You've still got work to do after that. You've got to divide it out. So I'm going to divide by x minus 1, right? Because remember, this is the factor. So if I was using long division, I'd divide by x minus 1. If I was doing synthetic division, what would I put outside? 1. See, all these things are little things. You're like, yeah, I remember that still, right? You won't in 3 months, right? You're going to have a good study sheet. So I'm going to put this in. 1, negative 9, 20, negative 12. Nobody's even missing. Okay, so let's do it. I drop the 1. 1 times 1 is 1. Negative 9 plus 1, negative 8. Negative 8 times 1, negative 8. 20 and negative 8 is 12. 1 times 12 is 12. 0. Okay, I'm glad I got 0. Okay, now, what does this mean? Okay, remember, this is the constant, this is x, and this is x squared. So I have x minus 1 times x squared minus 8x plus 12. See, that's equivalent to this right here, okay? But it says find the other roots. I only know one root so far. It's 1. How do I find the other ones? Well, let's factor out this binomial, and that's grade 10, right? What do you think is add to negative 8 but multiply to give me plus 12? Negative 6, negative 2. So it's x minus 1 times x minus 6, x minus 2. Okay, so what is this 0? When I see a 0 there, what does it mean? What is 0 equivalent to? The y. These are like the same thing. Whenever you see anything equal 0, 0 means y. That's the y-axis. Hence, oh, well, that's where the x-intercepts, I guess, always are when y equals 0. Okay, that kind of makes sense. Because what would be the points on the graph that would intersect? What are the points? 1, 0, 6, 0, and 2, 0. Okay, so it would look like something like this. Here's 1, here is 2, and here is 6. It would be doing this. Okay, that's the graph. Okay, a lot of stuff to kind of make sure you keep straight. So if you know the language well, and you can always draw a connection between the picture and the equation, which is the difficulty, okay? It is something that you have to practice and be able to kind of keep questioning yourself all the time. But make sure you know that roots equal x-intercepts, okay? They're the factors. Okay, we'll just go right to the assignment. Okay, I had a student come in today. She said, I watched the video, but then I forgot my book at home. But then I remember that you scroll through the homework. So I was able to get the homework done too. So that, it's worth it if just one person uses it. So we're doing 1 to 20. We're going to omit 5. And for 7, just do A and D. Okay? Now this looks like a lot, but except for 7, all of them are just one question. So you guys will finish. Oh, it's only like 10 after. Might have to start another lesson or something. Well, we'll see how it goes. Maybe you guys will start talking, telling me, Mr. Trammell, I want to start another lesson. Because I am unable to be responsible for my time. So can you please handle that for me? A pretty fun lesson too, okay? Right there. Second drawer, P2.